Alright, and welcome back to the course. I hope you enjoyed the previous section. I know it was a lot, but you powered through it. And don't worry if you haven't gotten very comfortable with all of the concepts yet, because we'll be reiterating a lot of them in this section. So what are we talking about this time? Well, we're talking about data frames. So what are data frames? And you might ask, Kirill, the word frame kind of implies that we'll be working with tables again. Aren't matrices for tables? Well, you're right. Matrices and data frames are very similar in the sense that they're both two-dimensional objects, and we're talking about working with tables and importing data into tables into R. But the core difference between matrices and data frames is that in matrices, all of the data has to have the same type. And as you recall from the previous tutorial, in all of our matrices, all of the data was numeric. But that's not always the case in real life, right? Sometimes you have a mix of data. Sometimes you might have character data, you might have categorical variables, and you'll have a mix of numeric variables, double, maybe even logical variables in there. And you can't simply import that into a matrix because it'll all be converted to one common type. So what is the solution? Well, the solution is data frames. And data frames are objects in R that also store tables, but they can have any types, any mix or combination of different elements in them, element types. And that is exactly what we're going to be talking about. And as you can imagine, this is our window into the world of big analytics. Now, once we master data frames, we'll be able to work with any type of data set. So I've got another very exciting challenge prepared for you. Let's jump straight into it. Can't wait to see you on the first tutorial.
Hello and welcome back to the course on R programming. Today we're going to have the project brief and we're going to download the dataset. So what is a project this time? The project is a demographic analysis. Very interesting. Let's see what we've got here. You are employed as a data scientist by the World Bank and you are working on a project to analyze the world's demographic trends. You are required to produce a scatter plot illustrating birth rate and internet usage statistics by country. The scatter plot needs to also be categorized by country's income groups. Okay, interesting, very interesting combination. They're trying to analyze birth rate and internet usage. So, what will that lead to? Is there any dependency there? Is there any correlation? What do you think? All right, we'll find out in this section. So, where do we get the data set for this section? Well, just like usually, we need to go to www.superdatascience.com/rcourse, one word. And here, if you scroll down to section 5, data frames, then the file you need to download is called demographic data, this one over here. It's a CSV file. Also, you can download the section 5 challenge if you like. That's the presentation that we went through just now. And also there's another file, but you don't need it just yet. You can download it, but don't open it yet. We will look at it later on. All right, so what's this demographic data? The demographic data is a CSV file, and the CSV stands for comma-separated values. And all it is just data in text format separated by commas. So I opened it with Excel, and if you don't have Excel, that's okay. You can open it with just a text editor. That's totally fine, and you will see pretty much the same thing. A good text editor is Notepad++. But otherwise Excel is good. So here we've got 5 columns: country name, country code, birth rate, internet users, and income group. So what we need to visualize is these two in a scatter plot and also categorize it by the income group of that country. We don't really care that much about the country name and the country code because it is kind of like a statistical approach, so we're not analyzing individual countries. We want to see the overall trend, what's going on in the world. That's what the World Bank is about analyzing these stats and seeing what kind of things are going on in the world right now, what trends they are. Now, what do these numbers mean? Well, birth rate, so let's start with internet users. It's a bit easier. It's basically the percentage of people using internet in that country. So how many out of 100 people have access to internet? 78%, 78.9% in Aruba, 5.9% in Afghanistan, 19.1% in Angola, and so on. And this data is for 2012 because that's the latest that the World Bank had for all of these combined statistics. And birth rate, well, it's a bit more complicated, but in essence, or like the general description of birth rate, this statistic, is that if you take 1,000 people in this country, for instance in Argentina, how many new people will be born in that same country in 1 year. So in that year, and it's measured somewhere mid-year, so that there's some more specifics to it, but basically that's the main idea, that you take 1,000 people, and per 1,000 people, how many new people are born in that country. And so basically if you add on any migration, like people immigrating into the country and emigrating out of the country, then that will give you the change in population for the year. But all we're interested in here is birth rate. So basically we want to see if there's any dependency or association between birth rate and internet users. Is there like any visible correlation that we'll see on the chart? So that's what we'll be doing in this section of the course, and we'll get started right away in the next tutorial. I look forward to seeing you there, and until next time, happy coding. Hello and welcome back to the course on R programming, and in this tutorial we will learn how to import data into RStudio. And we'll look at two methods, one where you will be able to choose the file manually, and another one where you'll have to set your working directory. So let's jump straight into it. The function that we're going to be using is called read.csv, and let's have a look at the help for that function. So if we zoom in over here, we can see that there's a function. It's got quite a few parameters, but all we're interested right now is actually the description. It says here, reads a file in table format and creates a data frame from it, with cases corresponding to lines and variables to fields in the file. So there we go. That's the important bit, that we are going to be reading this data into a data frame. All right, let's get started. So first method, we're going to select the file manually. And we're going to call the read.csv file a function, and in the brackets we're going to type in, instead of typing in the file itself, we're going to say file choose. So this function inside will create a prompt for us to select the file manually, and whatever this function returns, which will be a data frame, we want to put into an object, right? So let's create an object, and this object we will call it just stats, because we've kind of overused the word data already in the past tutorial. So let's work with stats for a while. So if I run this line now, what will happen is a pop-up appears, and from here I can navigate to my file like I usually do, and I can select it. I'll click open, and there you go. So the stats have been imported. You can see them over there, and if I run this variable, you will see that the stats are indeed here. So I can make some space, do that again, stats, there we go. So you can see that the same file that we looked at previously is now in RStudio. All right, well, that's great. Now let's look at method number 2, because sometimes in your work with R you will need this one. Actually, more often you will need method number 2, where you set the working directory and read data from there. So first, what is a working directory? Well, the working directory is where by default your RStudio goes to save files, open files, or do like even save the R files that you're creating and so on. So that's what a working directory is. How do you find out what it is currently set to? Well, the easiest way is to type in get wd and then brackets, because it's a function, and if you run that, it'll tell you what the current working directory is. So for me, it's currently my desktop. So that's not exactly what I want, because I want to save my files in a folder that I have on the desktop. So how do I do that? Well, you need to type in the function, which is setwd. And here you'll be able to supply the path to where your working directory is. Now, the tricky bit is that set working directory works differently in Windows and Mac. So let me type in the command that you will need to type in for Windows, and then I will show you how to do it on Mac as well. So depending on which machine you're on, you will use one or the other. So let's start over here. Let's start with Windows. So in Windows, if it's on your desktop, you would type in C:, then you would type in /users, /your name or the login, desktop, /, for me it would have been, for instance, R programming, if that's the folder's name, right? For Mac it's different. For Mac, you would type in /users, so / single quotes, and don't forget the quotation marks, / your name, in my case it's Kirill Eremenko, that's the username, desktop, and /r programming. So you can adjust all of these based on where exactly your folder is. It might not be on your desktop, or in Windows it might not be on your desktop, but basically that's the concept. You find the drive and then you select where you want to go, and on Mac, so you just start with users and then your name and so on. Alright, so I'm going to run the Mac one because I am on a Mac right now, and if I run that, you will see that my working directory has been set without an error, which is always good news. And now if I look at getwd, you'll see that my new working directory has been changed to exactly what I want, to that folder on my desktop. So now I can import the file using the second way. So I'm going to overwrite our variable that we have, stats. In fact, just to make this absolutely clear, or like the experiment is going to be unjeopardized, I'm going to remove stats. So I'm going to type in rm stats. As you can see, the object has been removed, and now I will populate it with the value that I want. So I'm going to type in read.csv. And now what I'm going to do is I'm going to type in the name of the file in quotation marks, so demographic data.csv. And now if I run this line, you will see that the object has been imported without me having to select it manually. And now if I select stats, you will see that the same file is here. So there you go. That's two ways how to import data into RStudio. And in the next tutorial, we will start exploring our dataset. I look forward to seeing you then. And until next time, happy coding. Hello and welcome back to the course on R programming. In the previous tutorial, we learned how to import data, and we looked at two methods. And today we're going to explore our dataset. So let's get straight to it. I'm just going to continue in this same file, and all I'm going to do is just put a separator here. So there we go. That's our file, that's our data, so stats. How would you explore the data that you have imported, right? How would you go about exploring it? Let's just type that in here, exploring data. Well, one way is to just run the line and see what comes up, and just look at your data set over here. But as you can see, we have quite a large data set. It's over 100 rows, actually 195 rows, and it's like there's a lot of data to look at visually, and you kind of get lost. And imagine if you had even more columns or even more rows, you'd get even more lost. So what are the ways that we could explore some data? Well, there are a couple of functions that will come in handy, and the best way to learn these is to kind of just write them down probably, and then once you've used them a couple of times on different data sets, then you will remember them, because there is quite a few and you definitely won't remember them right away. But as you start new projects on and on and on, and you use these functions, you will get used to them. So the first function is nrow. It basically just tells you the number of rows. So 195. And because we have a data frame, right, so we always know it'll be a two-dimensional object. It has some columns with names and then a number of rows. So the number of rows can be important sometimes, and especially if you want to check. So back when I was in consulting, it was very important for us to always audit what we're doing, always have a trail. And once you've imported data like we did here, you would always have to count the rows. And like we mostly did data imports into SQL, and you would have to count the rows and then actually put a comment like this saying here, imported 195 rows. So for verification, so if something goes wrong, you can always come back and check that, oh, actually, yeah, I can see where the mistake was, that we imported less rows than we actually supplied or something like that. So always a good thing to do after you've imported the file, check the number of rows and does it make sense? Is it a reasonable number? Is it what you expected? Number of columns, stats. So here, and once again, stats is just the name of an object, could have been anything else. That's what we're supplying to the function. So number of columns is 5, and basically, yeah, we can actually see that there's 5. But if there were like 100 columns, or you would use this function to once again assess how you've imported the data, or basically if it's a new data set that you're not really familiar with, you might want to know how many columns there are so you know what to expect. Next comes a pair of functions which I always keep getting this one wrong, or kept getting this one wrong. So it's called head, and what it does, it tells you the top 6 rows. So just basically, if you have a large data set like we do and it doesn't fit into this screen, if you just want to look at the top 5 rows, then you just type in head stats, and then you will see the top 5 rows. Why is that convenient? Well, because it actually shows you the column names, and not just by themselves. It shows you the column names and some sample data right away, so you can kind of get a feel for what the data set looks like. The other function that comes in pair with the previous one is tail stats, and this one shows you the bottom 6 rows. So this way, same thing, you see the column names, and you see the bottom 6 rows. So that's useful if your data is ordered by alphabetically, like ours is. It's ordered by country code, so you can see what's at the bottom, and like maybe there's different things going on here, so like kind of a different sample of the data. And the way to remember it is, I always kept thinking top, because in SQL, in SQL, basically the function is called top, and I always kept getting it wrong. The way to remember it is, think of a fox, right? A fox has a head and a tail. So basically that's what you're doing. You're looking at the head and you're looking at the tail. That's the way I remembered it, and maybe that'll be helpful for you. All right, and the other thing is, with these functions you can always say comma n equals whatever 10, and it'll give you more rows, right? Or same thing here, n equals, let's say 8. It gives you 8 rows instead of 6. So if you want to see a bit more, then just type in that. All right, and so what is the next function? The next function is str, and str stands for structure. So if we run str and pass it our data frame, then what we'll get back is a quick debrief of this data frame and what's going on in there. So first we get the number of rows, 195, number of columns, 5, and then it tells you a little bit about every single one of these columns. So let's have a look at them. So country name, it says factor with 195 levels. Now, in order to understand what a factor is, let's first start with the income group, because it'll be a bit easier that way. Factor with 4 levels. So what could that mean? Well, what that means is that there's a variable here which has been taken as a categorical variable. So we've got lower, middle income, low income, and I can tell you right now we have lower middle income, upper middle income, low income, and high income. So 4 types of income groups, or four different income groups we have here. And so R has picked that up. R has understood that this is not just some random text that we've placed here. It's actually a factor. So we might want to group our data based on this information sometime later. And what R does is it assigns numbers. So it assigns numeric values to these words, to these strings, attaches to them. So here you've got an example with 4 levels. High income is one of them, and then comma, etc. And then it tells you how the numbers, what numbers it has assigned. So it's assigned number 1, 2, 4, 4, 1, 1. So if you look here, not in the last rows, in the first rows, if you look here, you'll see 1, 2, 4, 4. So that's how it's assigned the values, attached the values, and basically that's R's way of dealing with categorical variables. And for us, they're called factors. Now, what R has also done, it has assumed that the country name and the country code are also factors. So it ended up with 195 levels. For us, it doesn't really matter. We're not going to use those variables, so we don't really mind what R does with, like how R treats them in the background for itself. But it's also a good check for us. Now we know that indeed there's no duplicates, because there's 195 rows and R has picked up 195 different levels. And same thing for the country code. Okay, and also we have birth rate. R has told us that it's a numeric value, and internet users also a numeric value, and it's just giving you some examples. So that's the str function, and actually it's one of my favorite functions, because if I were conducting a job interview, if I was interviewing somebody for a data scientist position, there would be 2 functions that I would ask them, like off the bat, right? The first thing I would ask would be, what does str stand for, and what does runIf stand for? Because these functions have such tricky names, people who don't know R well enough will inevitably get them wrong right away, because str in many other languages means string, right? It means convert something to a string, or working with strings and so on. So like sets of characters. And so unless you actually know that in R it stands for structure, you'll get that one wrong. And R run if, what that does is, it's even you can see that like I read it wrong. The proper way is RUnif, because it stands for random variables distributed uniformly. So remember we had R norm. So that was same thing. R stands for random, norm is the type of distribution. Same thing here. R stands for random, unif stands for type of distribution. If you don't know R well enough, you will assume that that probably means run an operation if something is correct, right? So just a trick there, or kind of a heads up. You should probably remember these two functions if you happen to be at a job interview where I'll be interviewing you, which is very unlikely, I guess. Anyway, so that's str stats, and then the next one would be summary stats, and let's have a look at that. So summary basically gives you a breakdown for every single column in a different way. So str is very quick. This takes like a bit of space, so it's like a box. So here, basically, these are categorical variables. There's nothing interesting about them. It tells you how many fall in each level. So how many high income, how many low income. Well, that's pretty interesting, I guess. Then for numeric variables, it tells you the minimum, the first quartile, the median, the mean, the third quartile, and the maximum. Same thing for this variable here. So it kind of gives you the breakdown, so you can understand what type of distributions you have here, or what the ranges are for your data. So you wouldn't even try looking for birth rate over 50 because it doesn't exist, you can see right away. And same thing for internet users. This is a good validation. It tells you that, yep, your data is between 0 and 100, so it is a percentage, which is great. Okay, that's us for today. I hope those functions come in handy when you're exploring your data sets. And for us, they have already told us a little bit about our data set, which we will start slowly digging into from the next tutorial. And I look forward to seeing you then. Until next time, happy coding.